everyone. My name is Amrita Bhatnagar. I am in the CSE department of AKGEC. Today I am going to explain about the file system of operating system. Okay. These are the outlines which I will discuss in this lecture. Firstly, we will see what is the meaning of file and file. Then we will see what is file organization, how it is organized. Then we will understand about the file dictionaries. And then we will see what are the access method for the files and what are the file allocation methods. So firstly we will see what are the file systems. Firstly, a file is a collection of correlated information that is recorded on secondary or non-volatile storage like magnetic disk, optical disk and tape. Okay, this is a definition for the file. And next is the file system. What do you mean by the file system? A file system is a method an operating system uses to store, organize, and manage files and directory on the storage device. Okay, the file is managed by the file system. Now, what are the main properties of a file system? Files are stored on disk or other storage and do not appear when a user log off. If user log off, we cannot see files. Files have names and are associated with access permissions that permit controlled sharing. Okay, we have some attributes of the file like name. By the help of name, we can open a file, we can access the file, we can save the file. That's why this is another property of file. Now, what is the meaning of file structure? A file structure needs to be predefined format in such a way that an operating system understands. It has an exclusive defined structure which is based on its type. Okay, then file structure can be categorized into three parts. First one is your text file, second one is the object file, and third one is your resource file. What is the meaning of text file? It is a series of characters that is organized in lines. Now next is an object file. It is a series of bytes that is organized into blocks. And next one is source file. It is a series of functions and process. So we can have these three different type of file structure in our system. Now next is file attribute. A file can have these type of different attributes. First one is name, which we have already familiar with it. It is the only information stored in human readable form. Identifier. Every file is identify a unique tag number within a file system known as an identifier. Next is location. Points to file location on device. Next is type. This attribute is required for system that support various types of files. Size. Attribute used to display the current file size. Protection. This attribute assigns the control, the access rights of the reading, writing and executing the file. So for the protection of a particular file, we have some access rights to the user. It can be read, it can be write, it can be executed. So according to the access rights, user can use these files. Now next is time, date and security. It is used to protection, security and also used for monitoring. So when this file is created, the time and date will be saved here. And it is used for the security or monitoring for the file. Now, different file operations. Which operations we can perform on the files? Create operation, open operation. Create operation means when we create a file. Open operation when we save create and save a file, and then again we will open a file. Then this is known as an open operation. Write file means do the changes in the file, doing the changes in the file. And next is read operation. Reposition of seek operation. delete operation, truncate operation, close operation, append operation, and rename operation. These all are the attribute, all the operation which can be used in the file. Now, what is the meaning of file directory? File directory is like a folder which is used in the Windows. In the file directory, we store different files and its information. And these are the main following information which is maintained in the directory. The name. First one is your name. The name which is displayed to the user. Second is this is the name of directory. Type of the directory. Position, current or next read write pointer, location on the device where this directory is stored on the system. This is known as location. Size, number of bytes, block of words in the file. Protection, access control on read and write, execute and delete. And next is usage, time of creation, access and modification. So these are the information which is maintained in the directory. And directory also save the data about the files also. Fine. So it can contain multiple files and its information in the directory. So it is like a folder. Fine. You can see this is a diagram for the directory. You can see here this is a one directory and we have multiple files in the directory. Okay. Now next is file access methods. What is the meaning of file access method? File access is a process that determines the way that files are accessed and read into memory. Generally, a single access method is always supported by operating system, though there are some operating systems which also support multiple access methods. So, to access, when we create a particular file and store the file into the system, for again access the file, we have different method which is known as a file access method. Now, we have three different type of file access method. First one is your sequential access. Second is your direct or random access, and third is index sequential access. These are the three different access methods. Right? Now we will see what are these methods. First one is your sequential access. Sequential access means there will be some sequence to accessing a particular file. Number wise access will be done here. In this type of file access method, records are accessed in a certain predefined sequence. Okay, that's why it is known as a sequential access. In the sequential access method, information stored in the file is also processed one by one. Most compilers and editor access files using this access method. So this is the simplest method. Okay, it is the simplest method to access a particular file. Information in the file processed in one order after the other. Okay, so we will have here sequence, and this is the most simplest method which is used by the different compiler and editors also. Next is the random access. There is no sequence to access a particular file. In this case, all the files will have its own address and it can be randomly accessed. The random access method is also called direct random access. This method allows accessing the record directly. Each record had its own address on which can be directly accessed for reading or writing. Okay, that's why it is known as a random access, because it can be accessed directly. We don't have any sequence here in the accessing a file. All the files are having its own address, and by the help of this address, this random access can be done. Now, next is index sequential access. This type of accessing method is based on simple sequential access. In this access method, an index is built for every file with a direct pointer to different memory blocks. Okay, so in this case, we have index for accessing a file. By the help of index, it will be access will be easier. So in this case, we will have index like a book where we have index to find out a particular page from the book. Like this, for find out the particular file from from the secondary storage, we will have index. In this method, index is searched sequentially, and its pointer can access the file directly, right? And multiple level of indexing can be used. There can be also multi-level indexing to offer greater efficiency in access. It also reduces the time needed to access a particular record or single record. So in this case, we have index which fasters the process, because index will be searched sequentially and we will find a particular file directly. Now next is file allocation methods. We have different type of allocation method. We have two type of allocation method. First one is contiguous allocation and second one is non-contiguous allocation. Now this non-contiguous allocation method is again divided into linked allocation and indexed allocation method. Fine. Contiguous allocation. In this scheme, each file occupies a contiguous set of blocks on the disk. For example, if a file requires n blocks and is given a block B as the starting location, then blocks assigned to the file will be B, B plus 1, B plus 2 and B up to B plus n minus 1. Okay, it means we have contiguous allocation for the file. We don't have partition of the files here. Fine. This means that given starting block address and the length of the file in terms of blocks required, we can determine the blocks occupied by the file. Fine. Contiguous allocation means we can store our file in the secondary storage contiguously. Okay. We don't need to divide our file into parts. The directory entry for a file with contiguous allocation contains address of the starting block and length of the allocated portion. Now you can see this diagram to understand the contiguous allocation. You can see this is the secondary storage. Fine. Here we have directory information which have information about the multiple files. You can see here there are 5 files: count, tr, main, list and app. And directory will store the metadata about the files. Fine. For example, this is the file count and the starting of the block of the count is 0 and length is 2. Fine. What it means? It means you can see here the secondary storage memory, the count file will be stored here from the starting of the secondary storage. It will start from the 0 and the length of the file is 2. That's why it is contiguously stored in the secondary storage from 0 block to 1 block, because length of the block is 2. So file can be stored in these 2 blocks contiguously. Fine. Next file is tr. Now the starting block of tr is 14 and length is 3. What it means? Now the another file is stored in the block which is starting from the 14. You can see here this is the 14th block from where this tr file is stored, and the length of the this tr file is 3, so that's why it will take 3 blocks: 14, 15 and 16. So that's why it will take 3 blocks. Okay. Now you can see we have another file tr which have 3 blocks. Length of the block is 3, 14, 15 and 16. So tr is stored into the 3 blocks: 14, 15 and 16. Next file name is mail, and the starting address for the mail is 19 and length of the file is 6. You can see here The mail file is stored in the secondary storage from the block 19, and it is stored and contiguously 6 block is occupied by the file mail. Okay, it is started from the 19, and the next one is list, which is started from 28, and length of the list is 4. 28, you can see here 28 here, and 4 length of the file is 4. That's why it is taken 28, 29, 30 and 31 blocks. And last one is F, which is started for 6, and the length of the file is 2, 6 and 7. So you can see in the contiguous allocation, we give the contiguous memory location to the file. We don't break the files into parts and store it. We can continuously store these files. Fine. Now we can see here what are the advantages and disadvantages of this contiguous allocation. Firstly, advantage is extremely fast since the number of seeks are minimal because contiguous allocation of the file blocks. Because when we start from the first block, we can find out all the file in the sequence. That's why it needs limited access or limited seeks. Disadvantage of this method is that this method suffers from the internal and external fragmentation. You can see here, these are the internal and external fragmentation because these blocks are empty and it is not occupied by any file. Increasing file size is difficult because it depends on the availability of contiguous memory at a particular instance. In this case, we can not increase the size of the file because we have contiguous memory location. That's why we cannot increase the size of the file. This is the main disadvantage of the particular this technique. Now, next is linked allocation. It is we have like a linked list. In this case, in this scheme, each file is a linked list of this block that need not be contiguous. So that this is the type of non-contiguous memory allocation. The disk blocks can be scattered anywhere on the disk. The directory entry contains a pointer to the starting the and ending file block. So that in this case, like linked list, we have pointers and one block will have pointer for the another block. Each block contains a pointer to the next block occupied by the file. So we are giving here one example of file G. In the next image, you can see here, this is a directory information. For here, we have, in this case, we have only one file which start from the 9th block and end in the 25th. So in this case, we don't store length of the file. We don't store here length. We will store here end block, starting and end blocks. Here you can see here G is stored from the 9th block. Okay, so we have, this is the 9th block, and 9th block will have a pointer for the another block, which is because this is a non-contiguous memory allocation, so it can be stored in anywhere. That's why it will have a pointer. Okay, so that you can see here 9th block will have a pointer for the 16th block. So other part of the file G is stored in the 16th block, and then again 16th block will have another pointer 1. The another part of the file is stored in the one block, and so again one block will have pointer for the second block, and second block will have the pointer for the 25th block. Okay, so this is the end block which is stored in the directory. This information is stored in the directory itself. So in this case, we have pointers so that the data is stored non-contiguously. The file is divided into parts and it is stored in the anywhere in the secondary storage, but we have pointers here to find out the other part of the file system, and we will store here in the directory starting and the ending block. Now the advantages and disadvantages of this scheme. Advantage: this is very flexible in terms of file size. file size can be increased easily since the system does not have to look for contiguous chunk of memory. Fine, we can increase here. This is the main disadvantage of the first technique, where we cannot increase the size of the file. Next is that this method does not suffer from external fragmentation. This makes it relatively better in terms of memory utilization. We don't have here external fragmentation. Disadvantage, because of the file blocks are distributed randomly on the disk, a large number of seeks are needed to access every block individually. This makes link allocation slower because we need number of seeks, because this is stored in the file is stored in the different blocks, and these blocks are stored randomly. That's why we need more number of seeks. Okay, it does not support random or direct access. We cannot directly access a block of a file. A block K of file can be accessed by the traversing K blocks sequential access from the starting block of the file via block pointers. Pointers required in the link allocation incur some extra overhead. So main disadvantage of this technique is that we need pointers here, which increase the overhead of the technique. The main advantage is we can increase the size of the file, and we don't have external fragmentation here, but due to pointer, the overhead of the technique will increase. Next is your index allocation. In this scheme, a spatial block known as an index block contains the pointer to all the blocks occupied by a file. Each file has its own index block. The ith entry in the index block contains the disk address of the ith file block. The directory entry contains the address of the index block shown in the image. We will understand in this technique we have index, and how this index will use here we can understand with the help of this image. You can see here there is another file G. Again we are using same name for the file here, and this is the directory information. You can see here there is only one information about the GB, that is known as the index block. There is only one information about the index block, which is the number 19 here. You can see here this is the index block, and this index blocks will store all the different file contents or file blocks. You can see here we have different links from the 19. 19 will show there are different pointers from the 19 to 1, 19 to 10, 19 to 9, 19 to 16, and 19 to 25. What it means? It means the different part of the file is stored in the different non-contiguous allocation, and all the pointers is stored in the 19th block. That's why we have the information about only the 19th block here. So by the help of this 19th block, we can find out all the memory blocks. That's why it is known as an index allocation, or 19 block is known as an index block. Okay. Advantage: this supports direct access to the blocks occupied by the file and therefore provides fast access to the file blocks. It overcomes the problem of external fragmentation. And now the disadvantage: the pointer overhead for the index allocation is greater than in link allocation. Again, the disadvantage of index allocation is increased overhead due to the pointers. For very small files, say files that expand only 2 or 3 blocks, the index allocation would keep one entire index block for the pointer, which is inefficient in terms of memory utilization. However, in link allocation, we lose the space for only one pointer per block. Okay, when we use small files, if there is a small file, then we have to give an entire block for storing the pointers, which is increase the overhead or memory which will decrease the memory utilization. Fine. That's why this technique is not very useful, and in the case of small files. Fine. Okay. Thank you.